The story of electrical plugs and sockets begins quietly in the late 19th and early 20th centuries, when electricity was just starting to enter homes and workplaces. Early electrical connections were simple, often improvised, and not especially safe by modern standards. Wires were sometimes twisted together or connected with basic screw terminals, with minimal insulation and little regard for long-term standards. As lighting, small motors, and early appliances spread, different manufacturers created their own styles of connectors, each one optimized for its own products and markets. Governments and engineers gradually realized that a more organized approach would be needed, one that could balance safety, convenience, and compatibility. Over time, this realization led to national standards, and later to international references like IEC 6183 and IEC 69061. These documents do not erase the past, but rather describe and harmonize the many plug types that had already become established around the world. The result is a landscape of connectors that is varied yet documented, historical yet still in daily use. To follow this story, it helps to move slowly from the early days of electricity through national standardization and then to the international work of the International Electrotechnical Commission. Each step added structure to a field that began as a patchwork of local solutions. The progress was gradual rather than sudden, shaped by technical constraints, manufacturing habits, and the everyday needs of people using electricity at home. In the early years of domestic electricity, before any international standards existed, safety was primarily a matter of good practice rather than uniform design. Installers relied on their own experience, and manufacturers focused on making connections that worked with their own equipment. Wall outlets were not yet common, and portable appliances were rare, so the need for standardized plugs and sockets was less obvious. As more devices appeared, from irons to heaters and radios, the idea of a detachable plug and matching socket became more important. Countries started to develop their own national standards, each reflecting local voltage levels, wiring methods, and industrial preferences. Some adopted round pins, others chose flat blades, and some changed direction over time before settling on a preferred design. These differences were not necessarily the result of deliberate divergence, but rather of separate technical communities working in parallel. Once a pattern of use had been established in homes and buildings, it became difficult to change, because every installed outlet represented a long-term commitment. Step by step, national plug types became embedded in the built environment, and future decisions were naturally constrained by what already existed. Instead of a single global style, the world accumulated a set of regional solutions, each one effective in its own context, but not directly compatible with the others. This is the backdrop against which the later work of international standardization would unfold. The International Electrotechnical Commission, usually called the IEC, was founded in the early 20th century to help coordinate electrical standards across national borders. Its work covered many fields, from power systems to cables and measuring equipment, and over time it also came to address plugs and sockets. By the mid-20th century, different plug types were well established in many regions, and the IEC recognized that these widespread solutions needed to be documented rather than replaced. One of the ways this was done was through a reference document that would list and describe existing systems in a structured way. This approach accepted that national preferences could not easily be changed, especially when millions of installations were already in service. Instead of forcing convergence, the goal was to present a clear catalog of the main types, including their dimensions, ratings, and basic safety features. This allows manufacturers and authorities to understand what exists in other regions and to design equipment that can be adapted or supplied for different markets. The IEC does not have the role of imposing global law, but its documents are widely used as neutral technical references. The gradual, methodical style of this work matches the slow pace at which building infrastructure and household installations evolve. As decades passed and the demand for portable appliances increased, the importance of having a shared understanding of plug systems became more apparent to planners and designers. IEC 6083 is one of the key documents that emerged from this process of describing existing practice. Its full title refers to plugs and socket outlets for domestic and similar general use, for the purpose of establishing standard sheets for the main types in use around the world. The document is essentially a catalog that gathers information about national systems which have already been standardized locally. It does not create those systems, and it does not require any country to adopt a particular type. Instead, it presents technical details such as pin shapes, dimensions, current ratings, earthing arrangements, and compatibility aspects. The plugs and sockets described in IEC 6083 are often known by letter codes in everyday summaries, though the official document focuses more on drawings and tables than on simplified labels. The types included are sometimes called legacy types because they mostly represent systems that have been in service for many years or even decades. For designers of appliances, this catalog serves as a reference when choosing which plug configurations to supply in different markets. For regulators, it offers a way to see how their national systems relate to those used elsewhere. Over time, updates to IEC 6083 have added or clarified information while maintaining the basic role of documenting existing solutions. In this way, the document reflects a world of diverse historical choices, organized into a consistent technical format. Among the plug and socket types commonly associated with IEC 6083 are those often informally labeled with letters such as C, E, F, G, I, and others in public summaries. One widely used system features two round pins without an earthing contact, suitable for low-current devices in many countries. Another combines two round pins with a separate earthing connection provided by a projecting contact or side clips, forming a more robust arrangement for higher-powered equipment. There are also systems with flat parallel blades and a separate earthing pin used extensively in North America and some other regions. In the United Kingdom and places that have adopted similar rules, a three rectangular pin arrangement is common, incorporating features such as shutters and internal fuses in plugs for additional protection. In parts of the world influenced by Australian or Chinese practice, angled flat pins are widely seen. In some countries, including parts of South America and Asia, there are variations with three round pins arranged in a line or a triangle, each linked to national voltage and frequency standards. IEC 6083 gathers these diverse arrangements into an ordered set of standard sheets, each with precise dimensions and ratings. The document does not attempt to judge which type is best, but simply records them in a unified technical language. This helps reduce confusion when equipment crosses borders, even when physical compatibility still requires adapters or localized versions. Because IEC 6083 focuses on describing established national systems, it also reflects their historical character and incremental development. Many of the plug types in service today were designed when typical household loads were smaller, and when double insulation and electronic power supplies were less common. Over time, safety requirements evolved, and national standards introduced additional provisions such as improved earthing contact reliability, better mechanical strength, and protection against accidental contact with live parts. These improvements were often achieved while maintaining compatibility with earlier installations, which limited how much the geometry could change. This means that the systems described in IEC 6083 represent a compromise between tradition and modern safety expectations. Some countries have decided to migrate gradually from one national type to another, or to refine an existing standard to address new requirements. Others have maintained their long-standing designs, but added rules on installation practice, residual current protection, and appliance design. The document simply tracks these configurations as they continue to be used, without prescribing timelines for their replacement. In this way, IEC 6083 can be seen as a technical snapshot of a living infrastructure, one that changes slowly as buildings are renovated, appliances are replaced, and policies are revised. The everyday experience of plugging in a device is shaped by these accumulated choices, even if most users rarely think about the underlying standards. Alongside the cataloging of existing systems, there has also been an interest in defining what a more modern and internationally compatible plug-in socket might look like. This interest led to work on a design that could, in principle, be adopted by multiple countries over time as new installations were built. The aim was not to immediately replace every existing outlet, but to offer a technically coherent option for future standardization where national authorities considered it appropriate. This approach recognizes the long lifetime of electrical infrastructure and the practical difficulty of rapid change. The concept of a new reference design involved considerations such as compact size, reliable earthing, compatibility with typical current ratings, and adaptability to regional voltage and frequency values. Engineers also considered the possibility of maintaining some degree of compatibility with existing 2-pin plugs where it could be done safely. From these discussions and technical studies, a new formal document was developed within the IEC framework. Instead of describing legacy types, this document defined a plug-and socket system intended as a modern international reference. That document is known as IEC 60906-1, and it presents a complete set of dimensions and characteristics for a specific configuration suitable for household and similar uses. IEC 60906-1 sets out the details of a plug-and socket system designed for use in single-phase circuits up to defined voltage and current levels, typical of residential supplies. The arrangement uses 2 round pins for the current-carrying conductors and a third contact for earthing, positioned to ensure correct orientation and reliable connection. The body of the plug is compact and shaped to guide insertion into the matching recessed socket, reducing the risk of accidental contact with live parts. Dimensions are chosen to provide sufficient clearances and creepage distances for safety, while allowing the overall device to remain relatively small. The standard includes requirements for mechanical strength, temperature rise limits under load, and compatibility with cords of appropriate cross-section. It also addresses aspects such as marking, color conventions, and the coordination of ratings with overcurrent protection in typical installations. Unlike the many legacy systems it might someday supplement, IEC 60906-1 represents a cleanly defined starting point, created with the benefit of long experience from other designs. The document organizes these technical requirements in a systematic way with drawings, tables, and test conditions. Its existence offers national committees a ready-made option if they wish to introduce a harmonized system for new buildings or renovations in the future. Even though IEC 69061 was created as an international reference, its adoption has been limited and gradual. Electrical infrastructure tends to persist for many decades, and national plug systems are deeply embedded in construction practices, regulations, and consumer habits. Changing to a new standard involves careful consideration of cost, compatibility, and public understanding. Some countries have explored the ideas within IEC 69061, adapting elements of its geometry or safety principles to local needs. In certain cases, national plug types that resemble the IEC 69061 configuration have been introduced or refined, while still remaining distinct in formal terms. Elsewhere, authorities have chosen to maintain existing systems while focusing on other aspects of electrical safety, such as improved protective devices in distribution boards and clearer installation rules. IEC 60906-1 remains available as a stable technical reference, ready for use whenever a jurisdiction decides that the time is right for a more harmonized solution. In the meantime, the global picture is one of coexistence between older systems documented in IEC 6.83 and this newer reference design. The situation illustrates how international standards can guide long-term evolution rather than enforce rapid uniformity. It also shows how practical infrastructure decisions must balance theoretical harmonization with the realities of installed equipment and user familiarity. The relationship between IEC 6.83 and IEC 6.9061 can be viewed as a contrast between documentation and proposal. IEC 6.83 gathers the principal national plug-and socket systems that have been standardized and widely used, presenting them in a neutral and descriptive manner. It acknowledges diversity and records it comprehensively without prescribing change. IEC 60906-1, on the other hand, defines a specific plug and socket system that could form the basis of convergence if adopted by multiple countries. It is prescriptive in design, but optional in application, since each national or regional committee decides whether and how to implement it. Together, the two documents give a structured overview of where the world stands and where it could, in principle, move. Manufacturers of appliances and accessories can consult IEC 6008-3 to understand existing markets and refer to IEC 60906-1 when evaluating products for regions that might consider a harmonized system. Electrical engineers and planners can study both documents when designing buildings, infrastructure, and long-term transition strategies. The coexistence of these standards reflects a realistic approach to change in technical systems that are costly and slow to replace. Over time, incremental decisions influenced by these references may lead to gradual shifts in the mix of plug and socket types in use. Practical everyday use of plugs and sockets involves considerations that go beyond geometry and official documents. Voltage levels, frequency, and typical current ratings vary between regions and are tied to the broader power system. Plugs and sockets must be compatible with these parameters and must be coordinated with protective devices such as fuses and circuit breakers. Many countries use earthing arrangements that require specific contact positions and conductor identification, so plug designs must align with wiring conventions. Double-insulated appliances may use unearthed plugs, while equipment with exposed conductive parts generally requires an earthing connection. IEC 6008-3 and IEC 60906-1 both integrate these technical realities into their dimensional and rating choices. Over the years, increased attention has also been paid to issues like contact reliability, resistance to heat and tracking, and the mechanical durability of plug pins and socket contacts. Test methods included in standards help verify that products can withstand repeated insertion and withdrawal without excessive wear. In addition, many regions have developed rules limiting the use of adapters, multi-way devices, and extension cords in certain settings to reduce risks associated with overloading and poor connections. All of these factors contribute to the overall safety of everyday connections, and they interact with the plug systems described in IEC documents. Looking ahead, the landscape of electrical plugs and sockets is likely to continue evolving slowly, guided in part by the frameworks provided by IEC 6008-3 and IEC 60906-1. New types of loads, such as electronic devices with external power supplies and charging systems for portable equipment, have already influenced how people interact with outlets. At the same time, the basic need for safe, reliable, and mechanically robust connectors remains unchanged. Some regions may gradually adjust their standards, while others maintain established systems and rely on adapters and travel plugs for cross-border use. International trade in appliances will continue to depend on clear technical references so that manufacturers can design products suitable for each market. National committees and regulators can revisit their choices periodically, comparing the performance of existing systems with the possibilities offered by newer designs. In this context, IEC 6008-3 remains a detailed record of the main plug and socket types in widespread use, and IEC 60906-1 stands as a defined option for more harmonized future installations. The interplay between tradition and modernization will likely persist, with each decision constrained by cost, practicality, and user habits. Over long timescales, these quiet processes shape the everyday act of connecting a device to the power supply. Thanks for joining us for this calm look at the history and standardization of electrical plug-and sockets under IEC 6008-3 and IEC 60906-1. If you are still awake, please stand by for our next program.